me share my screen. Is my screen visible?
Yes, sir, we are able to see.
Okay.
Yes, sir, the screen is visible.
Okay. Uh, right. So, good morning to everyone and all the participants. And thank you, the organizing team, for inviting me for the part of this activity. So, I'm really happy that I'm part of this activity on the cloud security. Uh, One of the aspects of the security and nowadays the cloud computing in which we are integrating blockchain into the cloud computing system, and we have seen that uh, there are several research that is going on that how you can enhance the security of the cloud computing domain using the blockchain technology. And blockchain technologies is also an emerging technology that has been recently used in various domains like IoT, the healthcare, the cloud computing, and the other supply chain, all these domains. So basically, if you will see that this is not a new technology, it is comes from the cryptography. The foundation is the cryptography and the distributed systems and all this. And we will also learn that how the blockchain is basically suits the cloud and the distributed as computing and all this system. So we'll come one on that. So again, thank you for this introduction of myself. Today we will discuss that how we can use blockchain for the different applications of the cloud computing, and from the security point of view, we will see then what are security loopholes that we may have in the cloud computing and how we can address that using the blockchain technology. So, okay, uh, one uh, problem that we discussed in the cloud and the, you can say, other distributed systems is the resource allocation, right? So first we'll try to understand that what is basically the resource allocation, what is the complexity of that resource problem, and what are the security aspects that we have in the security in the resource allocation of that particular, you can say, uh, problem of the cloud computing, right? And then we'll see that how we can use blockchain for uh, mm, if we need to solve the problem of the resource allocation in the cloud and the distributed system, then how we can address that particular problem using the blockchain. Because there are several some problems, inherent problems with the centralized system from the security point of view, from the distributed point of view also. There are several inherent problems that can be solved using the blockchain. And I will also discuss some of the steps in which we can use blockchain as a tool for the further research. If the participants are from the masters and the PhD and the faculties are there, then we will have some discussion on that how we can use blockchain that can be used as a tool in the future research. Okay, so the first part, I think, because this FTP is already on the cloud computing system and the cloud security. So I think some of the lectures have discussed the basics of the cloud and distributed edge computing. Now we'll discuss the basics of this. That how what are the main things we have in this computing domain. So if you will see the cloud, then the cloud is basically a business model in which we provide the services on a pay-per-use model, and uh, um, we generally provide everything is provided as a service. So whether if it is infrastructure like virtual machines, or the physical machines, or that will be provided as a service, not directly to the user. That will provide as a service. And but the problem with the cloud is that there is a significant delay because the cloud servers are at a very far distance location, and uh, so there are several real-time applications that need uh, quick response from the server point of view. Now, because the cloud servers are at a very far distance, so there is a significant delay between the end user and the cloud server. To remove this problem, we have new computing domains like distributed edge computing, like mobile edge computing, and the fog computing, like cloudlets, the nano computers, the edge servers, and all this. So what we do basically, so this is the cloud computing in which the basic components are the virtualization, the internet technology, the grid computing, utility computing, the autonomic computing. So again, cloud computing is based on these components, in which virtualization is one of the main components. Now, as I have discussed that in the cloud, in the edge computing basically, the problem with the cloud is that we have a significant delay um, for the cloud computing, and we know that if we talking about the IoT devices, then we have a significant number of IoT devices which are going to sense the data and then transmit the data to those cloud servers. But there are several real-time applications like cognitive assistance and the augmented reality, virtual reality, and like traffic monitoring, the vehicular tracking, and the interactive video streaming. So these are the examples of some of the applications which need real-time response. And once these applications are going to generate some data and they are going to send the data to the cloud server, then we have a huge data transmission over the internet backbone because they are at the distance server at a very far location. So we have a several number of switches and the internet network that comes between the end user and the cloud server. So we have a huge delay. So delay, it means we have to reduce the latency that we have to reduce. So people have thinking about that, and what they have done that this is the end user and this is the cloud server. So we have a several, you can say, intermediate locations we have. Now they have reduced this. They have removed this, and if this is the end user, they have placed the server like this at one hop, or let us suppose at two hops. So for example, if you are using some mobile and your mobile is connected to the base station, the network provider. So so in that case, in the mobile edge computing, what we are doing basically, we are putting the servers as a base station so that the request that is done by our mobile can be processed quickly, right? So in that case, uh, okay. So is everything okay? Is voice is okay?
Sir, it's breaking somewhat, but it is audible.
Okay. So let me change the.
Now is it okay?
Yes, sir, it is working fine.
It better or it is
It is better.
it is better. Okay. Right. So now we have to reduce this particular delay. So that's why we have these as technologies in which we are basically we augment the cloud computing by bringing the networks and the computational resource near to the end user. So likewise, I have said that if this is the end user and if this is the server, so these end users can directly access these servers. Previously, we do not know the locations of the servers, but as of now, we directly know the locations of these servers. So we are bringing servers near to this end user, and that is the advantage of the edge computing. So in edge devices, we have what edge devices can be. It may be a router, it may be a gateway, it may be a switch, or it may be some other base stations that we have, right? In which although these edge devices are not going to have a very huge computational resources likewise we have in the case of cloud computing, but we have sufficient computational and the storage resources to meet real-time and resource intensive demands of the end user. they have not so much computation capacities, but they have some, you can say, moderate computational and the storage resources, right? If we going to tell the names of the edge technologies, then a few names like the fog computing we have, like multi-access edge computing. Some it is also called the mobile edge computing. Then we have the cloudlets, we have the micro data centers, we may have the nano data centers. So these comes between the cloud servers and the end user, and they are near to the end user so that they can process the request locally, and they can give the response in a very fast manner. So that is the main property of the edge technologies. Now, these are some applications of the edge computing, in which, if you're talking about the industry, then we can build the automations, because automations need quick response. We have the structured monitoring, we have the actuations. If you're talking about the lifestyle, then we have the wearable gadgets, which also requires the very less latency, like gaming and augmented reality. And for the fitness, like smartphones and all these, so they again need quick response. Then we have in the healthcare also, for example, the remote patient monitoring, the body area network, elderly care. So for example, let us suppose if we have put some sensors on the body of a old person, very elder person, and if he falls, then there will be some changes in the readings of the sensors, and that sensors values has to be uh, analyzed quickly, and an instant notification should be given to the doctors as well as the other members that are the part of the hospitals, or like the care partner. So in those applications, if you will see that we need quick response, okay. In the energy also, in the automotive also, there we have several applications of the edge computing. Now means likewise, if you will see the real-time requirement, then the edge computing have higher real-time requirement as compared to the cloud computing applications. The applications of the edge computing, like I have discussed, is like gaming, the smart grid, the smart homes, the speech and the image recognition, the health monitoring, and the intelligent transportation system. But if you're talking about the frequency of the data transfer, then you will see that there is not so much data transfer between the cloud computing servers and the end user. But if you'll see from the edge computing point of view, then a huge amount of data is transferred from the end user to the edge servers. So let us take one example. We have installed a very large number of camera on each junction point in a smart city. Now these camera are going to capture the images or the recordings of uh, every moment of all the streets. Now for a detailed analysis, they are going to send the data to the cloud. Now if we are going to send the whole data, then definitely it is a storage problem. But what happens that if you are going to put a little bit server near to those camera, so those camera are going to first send the data. So if this is, you can say, this is the you can say some kind of, you can say, camera. So if you are going to put some small servers between the camera and this, you can say, so this is the cloud server. So we are going to put some server as server here. So what this as server will do, this as server will, you can say, compress, it will compress the videos, so that not all videos will be transmitted on this particular cloud server. So definitely some kind of, you can say, filtering also we can do, some compression we can do on these videos. So that would be very beneficial. And likewise on these edge devices, we can do some kind of, you can say, small processing, real-time analytics we can perform on these edge servers, because they have a sufficient amount of computational and the storage resources. So the data transfer between the edge and the cloud is higher as compared to the cloud computing domain. Now the problem with the cloud computing domain is that it is more and more centralized. If you will see, then let us suppose there are thousands of servers, one from the, let us suppose, from NIT Jaipur, one from the NIT Jamshedpur, and there are several users which want the cloud resources. And there are several cloud service providers also. For example, we have Amazon AWS, we have Microsoft Azure, we have Google App Engine. So there are several cloud service providers that they provide the services. So if now now these resources are limited, right? If, although cloud says that it has infinite resources, but these resources are limited. So if you will see, definitely there will be some broker which is going to detail out, which is going to allocate these resources to these users. Now this has to be, you can say, managed by a central entity. So that is not a good. Basically, it may happen that the users want that uh, it is not trustworthy. The cloud broker is not trustworthy, right? And one more problem is that we have a single point of failure or bottleneck problem. So single point of failure, let us suppose that the software that the cloud broker runs fails, or let us suppose the machine on which the cloud brokers head fails. So what happens that the whole process will be stopped. So in this case, we have to think about that how we can make it decentralized. See, if you will see these two technologies like cloud that we are discussing and the blockchain, if we will see these two technologies, then both are the distributed systems, right? So, but there are several central things that we have in the cloud. How to make that decentralized? If we're talking about the blockchain, then the main purpose of the blockchain is to provide the security and to maintain the decentralization, right? So I will advise every participants. I think something is there. Okay, nothing is okay. So uh, I will advise all the participants to use blockchain as a tool in which if there is something centralized thing like voting that you need to make it decentralized, right? Then use the blockchain, right? Or let us suppose you need to store some information in a decentralized way, not on a centralized manner, and you want that the data should not be tampered, that you can use blockchain. We'll come on that, right? So the cloud broker is the central entity, so we have to make it decentralized, right? We have to make it decentralized. So for that we are going to use the blockchain. And the problems, so there are three problems that we have in which the computation offloading. So I will give you the brief about these three problems. In the case of computation offloading, it is a process in which we transfer the compute intensive task of a resource constrained device to a remote monitoring computing server with significant computing capacity, right? So in this problem we generally decide that when we have to offload, where we have to offload, and that is a decision making problem, that whether we need to offload or not, and that depends upon several parameters. So that is generally of optimization problem. So all these three problems are optimization problems that we generally deal with. Then we have the service placement problems, in which the placement of application components like microservices tasks on a single monolithic server to fork node or the fork resource. Right now, in the third problem, we have the virtual machine allocation, in which we are going to allocate the virtual machines of an edge server providers to end user. Now, so that is the general resource allocation problem in the distributed as computing system, where we have this is the cloud. So this structure I have discussed earlier. Now this is the cloud computing domain, and this is the edge server, and these are the end users. So end users are going to offload the you can say the data to the edge servers, and we have a very short communication delay because they are near to end user. If you're talking about the cloud computing and the edge servers, then they are going to have a long communication delay because that is far from the cloud computing domain, right? Now we have certain challenges. So this is a very important slide, that where we have to focus that there are certain challenges in the centralized computing uh, resource allocation model. The problem with the centralized is that, for example, we have the lack of transparency and the trustless environment. So like I have earlier said, that if there is some cloud broker, and if you think that there is no trust in that particular cloud broker, so uh, there is some transparency issue in that, right? You don't trust the cloud broker, you need a trustless environment. So for that you can use blockchain. Second is that single point of failure. So likewise I have said earlier, that what happens if that the software of that particular, you can say, cloud broker fails, then it may have some attacks like DDoS attacks or any other attacks. So from the security point of view, whenever we have a centralized thing, it creates a problem, right? Then we have the mutable environment. It means that let us suppose some information that a particular central entity can tamper. So if that, for example, let us suppose talking about the healthcare system. In the healthcare system, if there is some patient data, and that patient data should not be tampered, but a particular hospital, because they have the control of that data, so they can tamper that data, uh, the patient data. That should not happen, because now why it happening, because it is centralized, right, and it is not trustworthy. So and so this is the problems with the centralized systems. And the other problems are like bottleneck problems. We have the security and the data integrity, and the lack of control over the data and the anonymity, right? So these are some problems we have with the centralized system. Now, uh, although the cloud is a distributed systems, but again in the cloud we have several things which are centralized. Likewise, one problem I have discussed. So from the theme point of from FDP theme point of view, from the cloud security point of view, there are several things in the cloud computing which are centralized. So we have to make them decentralized, we have to make them secure, and we have to make them more trustless, we have to make them more transparent, we have to make them more privacy aware. How we can do that? So people have started working on that to remove these problems, and then blockchain is one of the way in which we can solve these problems, right? Now, blockchain. So let us try to understand the basics of the blockchain, and then we will see in how we can apply the blockchain into this particular the cloud computing domain. So blockchain is a digital distributed database, popularly known as a distributed ledger. So it's a distributed ledger basically, in which the blocks are going to store the history of digitally signed transactions in a period that are linked using the hash pointers. So it's generally a ledger in which the information is connected to each other, and uh, once the data is stored, then we have some consensus mechanism through which we cannot tamper the data. If we are going to tamper the data, if we are going to change the data, then the whole data will be changed. So that is ensured by the blockchain technology, right? The blockchain became popular after the introduction of the Bitcoin in 2008 by Satoshi Nakamoto. That was the pseudonym. And starting the but there is one doubt, one confusion among the students and other mm, academic fraternities, that blockchain is just for the you can say finance, right? But not, it is not about the cryptocurrencies, it is more than about, right? So likewise, I have said earlier that it has several applications like edge computing, IoT, supply chain management, healthcare, and there are several other applications that we have in the blockchain. If we're talking about the structure of the blockchain, then blocks are connected by the hash pointers, which is similar to a linked list, right? And the transactions, cryptographic hashes create a Merkle tree in each block, and transactions in which we have in the Merkle tree, basically we are just going to, you can say, if this is the transaction and we have is a hash, we are going to combine the two hashes, and this process is iterative, and we are going to make a single root like a tree data structure. So this is happening because if you are going to change here, then the change will reflect here, the change will reflect here, and the change will be reflected here. So rather than checking every transaction and every hash, you need to just check whether the root has been tampered or not. If the root has been tampered, it means somewhere the information is tampered. Okay. And we have a concept of digital signature. We have a concept of private key, we have a concept of public key. So these are some of the way in which we are going to authenticate the participants, the users. From the security point of view, it is very important, right? So uh, anything that you're doing into the system, that they are going to verify it using the public and the private key and digital signatures. So for example, if someone has sent done it particular transactions, and it has to be digitally signed by that particular member, so that it cannot uh, change, it cannot deny that he has done that particular transaction. Okay. Now, the important part of a particular blockchain technology is the consensus mechanism. So this is not a new thing. It is a very old thing, and it was into the distributed systems also, in which a centralized systems have a central authority for the decisions, while decentralized systems rely on the consensus. Okay. uh, because in a centralized system, a single authority can take the decisions, but in a decentralized systems, we have several entities which are going to take some decisions, and consensus mechanisms ensure agreements in the decentralized systems. So they are going to ensure that that if there are three entities, they agree on a common thing. But how this agreement happens? So definitely there should be some communication. So let's suppose there are three entities that need to be, so that need to be, you can say, uh, there should be some communication between these three nodes, and there are a very less chance that they are going to agree on a common goal, right? So that is a very difficult problem for the distributed systems, and it may also happen that some of the nodes may fail, or some of the nodes may fail false information, right? So now the leaders going to select the transactions, and they are going to form the blocks, and they're going to propose them into the blockchain. But the main problem is that how we are going to select the leaders. Right. So how we are going to select the leaders, that we need to decide, and that is done by the consensus mechanisms. So in this case, there are several examples of the consensus mechanism. One is the proof of work, one is the proof of authority, then one is the practical Byzantine fault tolerance, then we have proof of stake, proof of reputations. Also, we have a long list. So if you will see, we have a long list of the consensus mechanism, and so like proof of work. So let me briefly discuss these consensus mechanism. So in a proof of work, a computational puzzle is solved, which is you can say the miner or the node which is going to solve this particular puzzle first, it will become a leader. In the case of proof of authority, it is generally taken by, you can say, it depends upon the reputation of a particular participant. So the node who has higher you can say reputation becomes some kind of authority who can take the decisions and become the leaders, right? So there are, so in a similar way, definitely there should be some mechanism through which a particular person need to be selected, which can verify, and which can verify the transactions, and he is going to form a block. Okay. Now, if you will see the characteristics of the blockchain, then first is the properties of the blockchain is the decentralization. So decentralization ensures that the distributed ledger among nodes replace centralized control. So uh, a single authority has no control over making the decisions. If there are several entities which are going to collectively make a decision, and that depends upon the leader selection, and that depends upon the consensus mechanism. The second property of the blockchain is it is immutable and tamper resistant. So the ledger that we have in the blockchain is immutable. It means once the information is recorded into the blockchain, that information we cannot replace. It means if you are going to change that particular information, then the blockchain will becomes invalid. And because all the information is connected, and that is using the hash link blocks prevent unauthorized changes. Okay. Then persistency, it means all the transactions will be verified by the miners, and the consensus mechanisms ensure that there will be no invalid transactions, and if we have a valid transactions, then they are going to form a block. and they're going to add the block into the blockchain. Then we have anonymity, right? So uh, in the case of blockchain, all the participants have their own public key, so they are not going to have their original names. So if the anonymity is there, it means they have some unique pair of public and the private key, and public key is known to every other person, but the private key is known to that person only. And the unique key ensure that the transactions they are going to perform, but without revealing their real name or real identity. Then we have a property of non-repudiation, in which this property says that once they have performed some transaction, then they cannot deny. It means uh, if and that is ensured by their public key and the private key, and this is done by the digital signature. So digital signature is a very important concept, and I think most of the persons know this particular concept. Then we have the transparency. So transparency, from the transparency point of view, we can say that all members can view and the validate transactions on the blockchain, because every member is going to have the blockchain and their transactions. Everyone can see and validate the transactions, and everyone see what happening actually, right? Because everyone has the copy of the blockchain ledger. Then we have the auditability. It means the immutable records allow the tracking and the verification of the past transactions. It means everything is recorded, nothing is tampered. So it gives us a very better chance to do the audit. Okay, I mean, okay. Now, depending upon who is going to control the blockchain, we have divided uh, the blockchain can be divided into three major categories. One is the public blockchain, which is open and decentralized, and anyone can participate and validate the transactions. And once a particular miner is going to do the verification, he quotes the award. Then we have the private blockchain, in which the particular blockchain is going to be controlled by a central authority, and we have a limited accessibility. In the case of consortium blockchain, it is partially decentralized. So there may be several organizations which are going to be part of each other, and they are going to they're partially decentralized. It means we may have more than one organization that they can become the part of one another. Okay. So now we have discussed the resource allocation problem in the cloud computing domain. We have discussed the basics of the blockchain. Now we need to understand, and we have also discussed that what is the problems with the centralized resource allocation in the cloud computing. Now we need to discuss that how the blockchain is going to benefit in the resource allocation, right? First benefit that we have from the blockchain is it is a decentralized authority. It means blockchain is going to enable the decentralized resource allocation through smart contracts, and it is reducing dependence on the central authority. It means that not a single authority is going to make the decisions. We have a consensus mechanism through which the leaders will be selected, and a particular miner is going to add the block, validate the transactions, and it is going to add the block. So there is not a single authority. It will be a collective decision, and it will be more transparent. Then fair. It means uh, we are writing the rules. Writing the rules means we are writing the smart contracts. The smart contracts are some, you can say, agreements or some rules which are going to be you can say executed by uh, automatically when some certain conditions will be met. So we are going to write the rules for the smart contracts, and that they are going to prevent the biased resource allocation, and they are going to ensure that the fairness when majority of the nodes are the honest. So it is ensured by the blockchain. Then security. Now, security was the main problem with the centralized resource allocation. Now, if we will see that blockchain cryptographic and the Merkle tree structure secure resource allocation against tampering and attacks when most nodes are honest. Okay, so we are having the concept of cryptographic hash functions. We are going to have the concepts of private key and the public key. We are going to have use the Merkle tree structure, which is going to ensure that whenever there will be some change into the information, the whole block will be tampered. The next benefit is the resilience to failure. It means with copies maintained by all the nodes, blockchain prevent the single point failure because it is decentralized. So we have no single authority. So it is always going to ensure that it is going to prevent single point failure, and which ensure that if some nodes fails, then it is that particular functionality, that particular system will work, continue to work. Okay. Then the transparent. Now, uh, because that particular ledger will be shared among all the entities, all the miners, all the, you can say, participants. So the whole things will be transparent. Okay, like resource allocation rules, like pricing mechanisms, payment mechanisms, everything will be transparent, and everyone can verify the transactions. So if you will see that the participants' point of view, so they can see the transactions, they can verify the transactions. So this process is going to become more and more transparent. Previously, what happening, that because it was centralized, so nothing was visible, right? So that's why we had the trust issues. Blockchain is going to address that trust issue, right? And it is going to make a trustless environment, right? Then attack resilience. So because we have the 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 design of the blockchain such that we have the cryptography, everything is encrypted, and it is not a single point of failure, so there are very less chance that it is resilient to the attacks, several kind of attacks like DDoS and these attacks. Okay, now the third part of this if this presentation is the blockchain based resource allocation models in the cloud computing and the distributed ASIC computing, right? So this thing we have discussed that the problems with the centralized resource allocation was that we have the collaboration among the competitive service providers, and the centralized problems running auctions can create distress among the service providers and the users. So, for example, the auctions that we have taken. So, let us suppose there are several uh, cloud service provider, CSP1, CSP2, CSP3, CSP4, and there is one broker. So, auctions means they are going to bid, right? And if they are going to bid something, then they are putting the resource request that they just want to sell. Now this particular broker is again a single entity, so this has to be replaced by the blockchain. So that particular competitive nature that they have, and this problem can be solved using the blockchains. So the blockchain with smart contract provide the transparency, the immutability, and the trustless resource management in the cloud computing. So that problem that can be discussed using, that can be solved using the blockchain. Now, one more problem with the centralized resource is that we have taken some use cases that a cloud service provider may deny providing services after agreement or paying the penalty in case of malicious activity, or a user may refuse to accept an offer after agreement or to pay a service, right? Now, uh, this is somehow the problems with the SLAs, and how these problems can be solved, that all the activities can be recorded, and then they can be later used for auditing purpose to decide on the real culprit. Now, the problem, now here, what is the advantage that we have is, the advantage that we have is that uh, because everything will be recorded on the blockchain. So let us suppose if there is some information which is recorded and that cannot be erased. If that cannot be erased, no one going to, you can say, claim that yes, I will not going to pay the penalty, because everything is defined into the SLAs. So SLAs means service level agreements is defined into the SLAs, and everything is defined. So no one can deny that no, I have not done that or like this, right? So blockchain is going to provide a, you can say, tamper proof ledger for that. for auditing purpose. Okay, then so that was the one example where previously what happening, that there are several service users and there are several the cloud service providers in which they are going to communicate with each other and they need to trade the resources. For example, these users need some services, these service providers are going to provide some services, there may be some negotiation, there may be some auctions. Now previously what happening, that there was some central entity which is going to do this, but nowadays it will be done by some, you can say, decentralized manner, and we are going to write the smart contract for that. It means we are going to write the rules that how can you allocate the services to the users. Previously we have rules, but how you are going to implement by a central authority. But as of now, because there are smart contracts and everything is written, and there will be no biasness, because if it is written, then it has to be implemented by a machine, it has to be implemented. And one more thing is that everyone can see what are the rules. So it is public, smart contracts are public, and you can say it is visible to every participants. So that makes this particular thing is very very, you can say, practical if there is some again a central entity and if you have to make it decentralized, right? Then many works advocate using the blockchain for resource management in the edge computing, but they require the validation, because in edge computing there are several works uh, that has been done, but they require some kind of validation, right? And blockchain platform supporting smart contracts can be used to design trustless resource management system in edge computing. Okay, then one more mechanism through which we can award, we can give the awards to the miners, that we can design some new coins also, in which that is going to improve the payment confirmation time, as well as we may have the credit based resource management systems implementing with the smart contract. So actually we have the edge servers, which edge servers, they have a sufficient computational complexity, but they are not going to have enough computational complexity, so they are going to do the mining. So if they are going to do the mining, then there should be some reports, right? Now, most of the cryptographic, you can say, blockchain technologies, if you're talking about the cryptocurrency like Bitcoin and the Ethereum, but some other, you can say, payment mechanisms can also be devised for the edge computing systems, like some kind of some new coin that is going to improve the payment confirmation system. And some applications like healthcare, cloud computing, and all these, they are going to need to be implemented on consortium blockchain, right? And why I have said this, that the consortium blockchain, because if you're going to implement on a Ethereum, then there is some serious problem we have, that because the resource management problems are very complex and they are generally going to be NP hard or NP complete, that is difficult problems. So the difficult problems, then we are going to write some kind of meta heuristics like PSO, GA, ACO, all these algorithms. So they are very long code we have. And if we're talking about the Ethereum, so Ethereum we're talking about, then all these things have to be done into the Solidity language. So if it has to be done into the Solidity language, then uh, we have a gas cost. Now, the one thing that we need to do is that in Ethereum, these resource management techniques has to be polynomial time complexity, so that there is a less gas cost, right? But the gas cost can be controlled in the private Ethereum blockchains, right? But for the public platforms like Bitcoin and like Ethereum public blockchain, it is very difficult for us to, you can say, control this gas cost. So that is a small limitations that we have if we are going to implement some resource allocation algorithms using the public blockchain platform networks. But it would be easier if we are going to do it in a you can say hyperledger or some kind of, you can say, private blockchain network. Right there. Now this is the one way that is our paper basically, in which we have several users and we have several as service providers. Now there is some blockchain system in which there are several miners. So these are the as servers. So these are the as servers, and the miners or also can be the as servers, but they cannot be the users because users have no interest in the mining process. So first what happens that the user are going to submit the requirements to the blockchain, and the blockchain is as server service providers are going to offer to submit the offers. Then this matching process will be going to be happen. Then if the matching process is going to be happen, then and these offers are going to be submitted on the blockchain, and this mapping is done by the smart contract, right? And they are going to validate the nodes, and this process happens. So previously what happens that we have these users, we have these service providers, and there was a central entity previously, but we have replaced with a collection of entities that is called miners. So what we have done that we have made the system, previously it was the centralized system, now we have made it decentralized, right? Now but in the case of you can say blockchain based resource allocation in the integrated cloud and the distributed edge computing systems, where we have integrate the as well as the cloud systems. So we have the problem of the orchestration of the cloud and edge computing creates a trustless heterogeneous computing environment. So security and the privacy becomes a challenging issue, right? So in this case, the smart contracts can act as a broker to provide the services of integrated cloud and edge computing to users. Now all these allocations rule, likewise I have said, all these allocations rule will be written into the smart contracts that will ensure the transparency into the allocation results. And we have the several malicious activities of the participants activities that also can be identified as the records of the activities, and they will also record it into the blockchain, so that later on we can impose the penalty or some other kind of, you can say, corrective measures we can take. And one problem with the cloud computing system and the edge computing system is that we have to maintain the quality of service. So if we have to maintain the quality of service, so there are several quality of service monitoring tools that can be installed at allocated computing nodes, that they are going to collect the data and that they can be, you can say, recorded in the blockchain to identify the SLA violations, right? So this is one framework, that is the blockchain-based resource allocation in the integrated cloud and the distributed edge computing techniques. Again, we have several users that they are going to submit the request, and we have cloud service providers that they are going to submit the services uh, to that particular broker. Now this broker is not centralized as of now. So we have several as computing service providers. So we have the resource offers from here, and we have the resource surface from here, and we have the request from here, and we have the smart contract layer also at this. So from this smart contract, we have some transactions which are going to be, so in the smart contracts are going to have some rules that how these resource offers will be mapped to the resource the resource request. And then we have certain rules that will be written into the smart contract, and then we have transactions. Now in the consensus layer we have the consensus mechanism. So we have several examples of consensus mechanism like proof of work, proof of stake, and proof of authority, proof of useful work, and that will be verified on a particular blockchain. And in the blockchain we know that all these are connected using some kind of chain. So that is the one model in which we can. So what was the main observation that we have that the blockchain based resource allocation replaces the central authority and uses a smart contract for the transparency, for the immutability and the integrity. Now these are some important, you can say, property that we have. Okay, and the smart contracts are going to replace the central authority for the resource allocation, uh, in which we have already this thing that uh, previously that everything was done by the central authority, but now because there is no single authority, so what we have done, that we have make rules for uh, that done by the central authority, and we have written those rules into the smart contract, and that smart contracts are visible to everyone and anyone can implement the smart contracts. Okay, so small and one more thing is that small cloud service providers can create a cloud federation to joint cloud using the blockchain technology so there will be no trust issue. So previously what was happened that we have a very big cloud service providers like Amazon and the Microsoft, but sometimes what happened that the to make it more fair, there are several companies or there are several cloud service providers which are not big as much the Amazon and the Microsoft. So what they can do, that they can create a cloud federation and they can make a collective you can say resources, and and that they can offer to the users, so they can then use the blockchain technologies like the federation, so that there will be no trust issue. So each cloud service provider will act as a miner also like this, right? Then uh, blockers also can create blockchain based resource matching platforms, and but the problem with the blockchain is that the scalability, right? So for example, the Bitcoin is very slow because we have proof of work. Ethereum is fast, and depending upon the application, we can create our own, you can say, matching mechanisms depending upon, for example, if it is a healthcare, so the private blockchain, you can say, the public blockchain platform like Bitcoin, it is very slow. Then we have Ethereum, but if you will talking about the private blockchain networks, then they are fast, right? Though, and it's totally depend upon the consensus mechanism. So there is huge research that how can you design lightweighted, fast consensus mechanisms, right? And so if it is slow now because we have so many entities, right? We have so many entities, so the system is not scalable basically. We have more and more number of entities, then we have more and more communication between all these entities, right? We need to reach one agreement, and this is going to take a lot of time, and that's why if we have more and more entities, then the system is not scalable. So scalability is also an issue, and a lot of research is going on that how can you make a blockchain system more and more scalable, right? So that is also a research problem as of today in today's world currently. Okay, then uh, other observations that we have from the blockchain-based resource allocation in the cloud computing domain is that designing the decentralized resource allocation using the blockchain is edge computing will increase the acceptance of the edge computing. Likewise, for the cloud is a well-known domain, but edge computing is still emerging. But if we are going to implement some, we are going to address some security issue of the edge computing using blockchain, then it will be more acceptable in the upcoming future, right? And uh, the blockchain-based resource allocation should support the joining and the leaving of the nodes at any time. And one thing that we have discussed previously, that no work implement in the meta heuristics in the smart contract for the resource allocation in the as computing, right? It means because in Ethereum we have the Solidity language, and the Solidity is very simple language in which writing the complicated functions is very you can say difficult. And why we are not writing the much complex functions, because it incurs the gas cost. Now the gas is limited. Everything that you are going to perform on the Ethereum, you have to pay the gas cost. Okay, so that is due to the overhead and the increased latency. and we have several meta heuristics techniques that requires high computational efforts compared to the simple heuristics, and because they are hence they are going to require higher gas cost. So simple heuristics like greedy. So if you are going to write greedy based heuristics allocation rules, that will be very fast and the less gas cost will be there. But if you are going to write like PSO, GA, ACU and all these, then they are going to have very high gas cost. Okay. Now we have certain challenges in the blockchain based resource allocation. Previously we have challenges in the centralized resource allocation, but we have also certain challenges also in the blockchain based resource allocation in the cloud computing domain. So one challenge that we have is so these are some of the challenges. So let me briefly discuss some of the a little bit, like consensus mechanism. So likewise, I have told you that consensus mechanisms like proof of work, that they are going to have a lot of, you can say, computational resources, and that is slow. And we have a issues of the energy consumption and all this global climate change and all this. Then as of now there is no global reference architecture for the blockchain, right? So likewise we have a global reference architecture for the Wi-Fi, and we have standards for everything, but for the blockchain we have not a global reference architecture, right? And then one issue is that the reputation and the trust management. So we have a network of the nodes, then uh, some nodes may fail. One problem is that the another problem is that some other nodes may behave in a different manner. I mean they are not you can say trustworthy. they are they 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 misbehave, or they behave in a different manner. They can be malicious. So how to handle that malicious behavior of the miners, that also need to be taken care of. SLA monitoring and like scalable. So likewise, I have discussed previously that we have to make the system more and more scalable. So if you have a blockchain based system, and if you have proposed something using the blockchain, that it has to be scalable, right? Then we have the security and the privacy. So in this case also, although the blockchain provides the security, but again this is challenges, and the privacy is also one more issue. See, the blockchain is going to uh, it is transparent, right? Blockchain ensures the transparency, but transparency comes at the cost of privacy, right? So somehow privacy is we have to maintain. So for the privacy there are several techniques like differential privacy we can use, and federated learning is one of the way in which you can ensure the privacy. So people have started working on the integrated framework of federated learning plus blockchain, right? Then we have the group signature, then we have the threshold signature, then we have the multi-party computation, then we have, so there are several ring signature. So there are several techniques that you can use to maintain the privacy of the end user in a blockchain based system. Then we have incentive mechanisms. So for example, let us suppose there are 4 miners, and each particular let's suppose a particular miner is going to add the block. Then there should be some reward mechanisms, that how we are going to decide the reward that is going to add the blocks. Or there are some other additional tasks like how to verify the transactions. So there should be some incentive mechanisms that should be developed for a blockchain based systems, right? And likewise, I have told you that smart contract the gas cost, how we can minimize the gas cost for the, you can say, more complex functions. Okay. And one problem in which we are also working is that you have to optimize both. You have to optimize the resource allocation as well as the blockchain parameters. So how you can jointly optimize these two things? You have to optimize the blockchain as well as you have to optimize the resource allocation parameters of the problem in the edge computing system. So we have to optimize both. How we can approach, how we can take one approach to solve this. Okay, so this is one of the challenges also. So let us summarize this talk. That so in the starting we have know that in the cloud computing, security is one of the aspect, And one problem in the cloud computing, one challenging problem is the resource allocation problem, in which I was working since many years. And uh, nowadays people have started working on blockchain based resource allocation systems, in which they have addressed the problems of like the security and the security and the transparency single point of failure of the centralized resource allocation in the cloud computing system. So we have started using the blockchain, people have started using the blockchain, and blockchain ensures the decentralization, the immutability, and the non-repudiation. So all these things can be achieved if we are going to do the resource allocation in a distributed manner in the edge computing system as well as the cloud computing systems. And blockchain is going to make a trustless environment. I mean, there is no need of trust. Previously, if the centralized system is there, then we need trust. But if there is no centralized system, then there is no need of trust, right? And it also ensures the trustfulness, the data integrity, and the data availability. Okay. And the smart contracts can be used to implement resource allocation methods and for the autonomous control. And the blockchain based resource allocation models going to become more robust by addressing the single point of failure that challenging in the conventional system, right? And the idea is that these the use of blockchain in the resource allocation makes the whole system transparent, so privacy becomes a little bit challenging, likewise I have discussed in the previous slide. So for that, the one thought that we can have, we can read about the federated learning, a very important concept nowadays. To maintain the privacy, we can use the federated learning. Okay, so what we can do, that we can integrate a blockchain based system plus a federated learning system. Okay, so that is and although uh, the blockchain ensures the decentralization, but the consortium blockchain seems the most suitable model for resource allocation distributed as computing system in cloud computing market. And because only the verified participants can participate in the consortium blockchain, some central authorities need for the verifications. Okay, and there are several lightweight consensus mechanisms such as proof of authority, PBFT, POET are more suitable than proof of work for resource allocation using concept, because proof of work is going to consume a lot of resources, a lot of computation power, and it is a huge challenge for the climate change. And definitely, we need to design some new consensus mechanisms that is specific to the resource allocation for in the cloud computing domain. So I will advise everyone to just focus on that how we can use the blockchain for the resource allocation problems, and we have to write some you can say novel algorithms in you can say private blockchain networks, that there is no issue of the gas cost as well as, and that is the cost effective. And that there should be some work on the incentive based mechanisms, that if there are some nodes which are participating in uh, if there are some nodes which are participating in the consensus process, then how we can design those incentives. The incentives may be based on the monetary, or it may be based on the reputations, or some other mechanisms, kind of you can say reward or some kind of point based system also. Okay, so that is my advice. So these are the references that I have used in my PPT. This is our paper. So if the interested one can refer this particular paper, that we have summarized a list of work that have considered the blockchain for the resource allocation problem in the cloud and the distributed edge computing systems. So that was published in the Computer Communication in 2023. Thank you.
Participants, if they have any queries, they can put up in chat box. So, sir, I think there are no queries.
Okay.
So,
Thank you.
once again, thank you, sir, for giving such wonderful insights on how we can embed blockchain in cloud computing, and that was very insightful. Thank you, sir.
Thank you. Okay. So may I leave?
Yes, sir. Yes, sir.
Okay, thank you.
So to the participants, the next session will start at 4 p.m.